I'm Alan Ross. I'm the managing editor of APC Technologies, and we are here at the NETA, the International Electrical Testing Association, their 2023 Power Tech Conference, doing interviews. My guest with me is the Director of Communications for APC Media, Rachel Linke. Rachel, thank you so much for being here.
Absolutely, Alan. Would miss it.
We're just going to have an interesting time with all of these people, and tell me what you like best about these interviews.
The best part about these interviews, I feel like, is that it really brings about a lot of great thought leadership, and I really just love how you make everybody feel so comfortable, Alan. You really try to get people to just be comfortable and in their own skin, and then so much great information comes out of it. So
let's see if we made people in the next interview comfortable. Enjoy. My next guest, I love the first name. It's Ross Ignall, since I'm Alan Ross. But Ross, thank you.
Thank you.
Ross is pretty much everything, product development, technology, and everything for Dranetz company. You've been doing it for 30 years, and they've been around a long time.
Yes.
Tell me a little bit about Dranetz, first of all, and a little bit about your background with them.
Sure. Dranetz was founded in 1962 by Abraham Dranetz. He basically started the power quality monitoring industry. He had an idea that people were more concerned about energy, but the changes and fluctuations in power quality were starting to become a concern with microprocessors, things like that, more sensitive load. So he basically founded an industry, founded Dranetz Technologies, and here we are more than 60 years later, making very current and appropriate instrumentation for the industry.
So I'm going to bring up a report I want you to comment on, because you said they started having problems. We are now moving into the EPRI, did a report in 2001. And in that report, in 2001, they talked about the billions of dollars of losses in industry in North America because of power quality issues. And that was before DER and all of the problems that distributed energy brought. But talk a little bit about that, about power quality and how we thought we solved it. Now we're creating even more problems that are going to have a tremendous impact on industry as a whole. Talk about that.
Sure. Well, it's an age-old problem. What's your susceptibility to power problems, and how do you evaluate that? And really, it's a dollar loss. People work on dollars and cents. Yeah. So it's been an age-old problem in the industry is quantifying that loss. And a lot of times it happens because you've had a loss, and then you're reactive to the approach. What we as a supplier of PQ monitoring equipment, we want you to be more proactive, try to prevent that problem from occurring. Yeah. And part of that is being proactive in monitoring these DERs, UPS systems, energy savings devices. Like you said, we thought we tackled a lot of the power quality problems. Well, we just introduced different types of problems, and you need different measurement techniques, and some of the international standards drive that. But it's all about the susceptibility and evaluating that susceptibility and comparing it to what you guys do, what a customer and end user would do, and what's the financial impact of that.
Okay.
That's a
you
big thing.
did a presentation here. In fact, you just came off the stage.
I did, yes.
So tell me a little bit, highlights of the presentation, just what you just said or more?
Sure. Well, we did sort of more or less a how-to on power quality triggers. There's some techniques used by power quality monitors, some defined by standards, some more proprietary, like those from Dranetz, and how do you apply them? There's a lot of confusion in the industry. So really what we take, and what I take, is a lot of the questions we get from our technical support and our customers, and try to educate the NETA customers and our customer base in general on how to better, first of all, how to understand what these things do, but how to apply them to their different sorts of applications. Not every tool within a meter applies to every type of application. So how they work and how to best use them for the applications, and that's what this talk was about.
There's another challenge that we're facing, and that is that as we move from an electromechanical, even though it's electrical system, there's a lot of electromechanical pieces of equipment out there. And now we're moving to solid state, we're moving to microprocessing.
Absolutely. Everything
is changing. That impacts power quality, correct?
Absolutely. Well, actually, it's the susceptibility of those devices to power quality problems. The PQ issues have been there. Some of them are getting a little bit worse, but these microprocessor controlled devices, which have been around for many years now, are very susceptible to that. And it's understanding, well, what is that susceptibility and what's the downtime associated with that? In fact, the prior presenter to my presentation, he does some of the signature analysis for stuff, and people are used to replacing devices regularly. Well, you don't have to do that if you fix your problem and it doesn't blow up your devices. And that's kind of the thing. Don't have your data center go down, whatever your load is go down. Be a little more proactive, capture the problems up front, and prevent that outage. You save money, you save time, save customers, or whatever your operation does.
So there's, as you do this, you've got technology to be able to detect power quality problems so that you can prevent power quality problems
Sure.
from but it depends on people doing it. A lot of people doing the testing.
Yeah.
We're here at NETA, and obviously they have NETA accredited people, but we don't have enough of them, and we need more of them. And now, as the demand for power is ramping up, for instance, Bloomberg just recently announced that whatever they predicted for adoption of EVs is 2.4x wrong. So it's happening quicker and at a scale that they did not even. That causes all kinds of issues for everybody.
Yes.
So relate the value of finding and fixing, remediating, rather than just having more technicians running around testing for quality.
Sure. I think it may rely on or relate to the effectivity of these technicians. Are they properly trained?
Okay.
Do they have the skill set to do it? As an example, in our industry, do they know what the products are? Do they know how to use the products? That's why I enjoy spending time at the NETA conferences. I've done full half-day seminars at the NETA conferences, about the industry. What are the techniques done in the industry? Not talking about our products specifically, but what are the best practices, certainly focusing on the power quality monitoring and making sure, at least from what I can do, that these technicians or operators are well trained in it. They understand and help to educate them, and so they can go out and do a more efficient job. And I think that may be part of it, increasing the efficiency of the folks out there doing the work.
Yeah, if you only have 10, but you need 20, you got to make the 10 better.
It's the world today, right?
That's exactly right. We don't have enough of it.
Yeah.
I'm a transformer guy. I think transformers are the heart of the system. Right? Everybody says cables are the
everything comes from
everything,
that, right?
But we are moving obviously to an inverter-based system. Inverter-based systems are different. Southern Cal Edison did some research, and in that research, they basically said that in an inverter-based system, transformers that have to take power in and send it down and take power in and send it up are aging at twice the rate that they were aging. That creates another whole set of problems in there.
Yeah.
What are the power qualities as it relates to inverters versus transformers?
It's a lot of the switching of the inverters.
Okay.
They're taking DC from maybe that alternative energy and creating it and changing it to AC. So the switching, the noise created by that. Also, there's some standards in the industry that allow for the control of these inverters from the utilities and making sure that that's happening on a structured basis and they're following the standards. They're not introducing problems onto the grid. That's the big thing. When you put something connected to the grid or anything, well, are they working well together?
Yeah.
And that's where the power quality monitoring comes in, to evaluating that from kind of an independent standpoint and metering that and make sure they work well together.
You mentioned NETA, that you've done a lot of presentations of NETA. Obviously, Dranetz has got to be able to support NETA. Tell me about that. Why is NETA important to you in the company? Why is it important to the industry?
I mean, selfishly, they're our customers, of course, so that part of it as well. But it's also important to educate the customer base and to make sure. I mean, we hope they're using our tools, but if they're using someone else's tools, they're doing it correctly, and they're making the most out of their investment in those meters. These things can be a little expensive, and how to use them more appropriately.
What's the future of technologies that relates to power quality detection and remediation, you think?
Well, interestingly enough, some of the standards that I referred to, I give a little annual update. I'm on some standards committees.
Okay.
The evolution of those standards, which is getting more involved in not only what you should be monitoring, but specifically how the instrumentation should be doing it.
Okay.
And instead of saying, I need to measure this, well, how do you measure that?
Okay.
And what that means is, in the end, if I'm fully compliant, I have different meters from different manufacturers are going to give you the same results.
Right.
And that's an age-old problem in the industry where they don't give the same results. And those standards are evolving into higher frequencies. And something called super harmonics is becoming a concern in the industry.
Ooh, tell me about super harmonics. That's a good one.
It's not
Never
like
heard
Superman.
that.
No, it's becoming a very common buzz.
Okay.
It's internationally. It's in a higher order frequency range from 2 kilohertz to 150 kilohertz.
Okay.
Where typically the harmonics in the present standards go out to the 50th harmonic.
Okay.
This is well above that. And really instrumentation like ours is going to be more like spectrum analyzers and oscilloscopes in the future. And these standards, in fact, one of the committees that I'm on, are developing the techniques to do those measurements with the approach of making sure that they're practical measurements that meter manufacturers can provide at a reasonable cost.
When you say standards, ASTM, IEEE,
IEC.
IEC
International
standards.
Electrical Technical Commission. So, yeah, the IEC.
Yeah, we support that. We're going to be at an IEC conference in September, I think, and Amsterdam.
There's a lot of them. In fact, they're driving a lot of what's happening in the United States, where the IEEE is basically taking what the IEC has already developed, and sometimes instead of reinventing the wheel in that regard.
I like to see that too. I'm a IEEE PES and a Reliability Society guy, and I think now that you see them accepting from each other, we now kind of really truly have two international bodies looking like one international standard, which is brilliant.
Absolutely, and I'll give you a real-world feedback on that. As part of the international IEC committee that I'm on, this Working Group 9, we're implementing some changes based upon suggestions from the IEEE. Feedback from other members, other U.S. members coming through the IEEE, back to the IEC to kind of get a more worldly perspective on the measurement. Instead of being very IEC based, let's include the United States and any other country that complies with IEEE standards in there.
Okay, and because I was excited about superharmonics, what causes superharmonics?
That's an interesting question. We just covered that in the session. A lot of it is they're concerned about inverters and the high frequency switching. In fact, a gentleman in there had some things with IGBTs in certain power supplies and different things like that. That's typically in the lower end of the superharmonic range, but there's a lot of susceptibility concerns over that, mostly in Europe with power line carriers, I believe, and other things like that, which aren't necessarily used as much here in the United States. But it's kind of all tied into the DERs and different things like that and the ability to measure. The IEEE is starting to get involved in that, to the best of my knowledge. I'm not on those committees, but it's certainly an international concern that's being reflected back here in the United States.
Okay. Last question for you. Dranetz, where's the company's been around a long time, great pedigree.
Yes.
Where's it going? What's the future look like?
The future is certainly leading the leading technology and making sure we have leading edge instruments when it comes to that. That's one of the reasons why me and other people in my organization are on these committees, so we can help develop it and improve the industry, but also know what's coming down the line. So we have the ability to be, kind of look ahead what we need to do. And the thing with these standards is you just don't redo your current instrument for that. You need additional computing power and different things, more memory, different DSPs, the more computationally intensive, which requires future engineering and things. And we don't want to develop our next generation to meet the next generation. We want to develop it for generations beyond that. This helps us keep our finger on the pulse of the industry.
Well, thank you for your support of NETA. Thank you for support of the industry, because we're all in it together.
Yes, I appreciate it. Thank you.
Thank you.
Take care.